Hello everyone. In this video, I will explain the Fourier series expansion of the given function. So first, what is a Fourier series? Fourier series is a way of representing a periodic function as a sum of sine and cosine functions. Now, what is a periodic function? Periodic function is defined as a real valued function f of x is said to be periodic function of period capital T if f of x plus t equals f of x. If a function f of x satisfies this condition, then we say that it is a periodic function of period capital T. So what are the examples? The examples are sin x and the cos x are the some of the examples. Why it is sine is a periodic function? You know that sine value, sine 0 is 0, sine pi is 0, sine 2 pi is 0. Means for every repeatedly it will give us the same value. So we call it as a periodic function. Now, the Fourier series expansion of the function f of x over the interval c comma c plus 2l of length 2l is given by f of x is equals to a naught by 2 plus summation n equals 1 to infinity an cos n pi x by l plus summation n equals 1 to infinity bn sin n pi x by l. What are these A again? A naught, An and Bn are called the Fourier constants. Now we will see what are the formulas for A naught, An and Bn. A naught is given by 1 by L, C to C plus 2L, f of x dx, and an is 1 by L C to C plus 2L f of x into cos n by x by L into dx, and Bn is 1 by L C to C plus 2L f of x sin n by x by L into dx. These are the three Fourier constant formulas. Next, we'll use how to evaluate these Fourier constants. First one is by integration by parts. U is the first function, V is the second function. U into V1. V1 means integration of second function minus differentiation of U, integration of V1, that is second function, plus U dash differentiation U double dash, V2 integration V3, again minus U double dash integration different derivative triple dash V3 integration V4 means alternatively plus and minus, minus plus again plus again minus and then plus. Now where we will get to how to obtain this U dash, U double dash, U triple dash are the derivatives of the function U which we treated as a first function. Similarly, V1, V2, V3 are the are obtained by integrating the function V successively. So this is the second function. Now we will use two more formulas also, that is integration of e power ax into sin bx dx. Its integration will be e power x by a square plus b square into a sin bx minus b cos bx. Similarly, e power x into cos bx dx will be e power x by a square plus b square into a cos bx plus b sin bx. These are the two formulas. Integration by parts, and these two formulas are extensively used to find the Fourier constants. Now, these some of the values we need to know. Sin n pi value is 0, sin n cos n pi value is minus 1 power n, sin 2n pi value is 0, cos 2n pi value is 1, cos 2n plus 1 into pi value is minus 1. These values are used while finding the Fourier constants, that is an and bn especially. Now, from general interval c to c plus 2l2, now we will move on to the a particular integral, that is 0 comma 2 pi. So what is the Fourier series expansion in this interval of length 2 pi is given, length 2 pi is given by f of x equals a naught by 2 plus n equals summation n equals 1 to infinity an cos nx. If the interval is in terms of pi, then we will get cos nx. Otherwise, we will get n pi x by l into plus summation n equals 1 to infinity bn sin nx. Again, this a naught, an and bn are called Fourier constants. Next, what are the formulas for that? A naught is 1 by pi 0 to pi f of x dx. An is 1 by pi 0 to pi f of x cos nx dx, and Bn is 1 by pi 0 to 2 pi f of x sin nx dx. So these are the formulas we'll use in the interval. If the interval is 0 to 2, in 0 to 2 pi, limits of the integral will also be same. Now we will move on to the Fourier series over the interval minus pi comma pi. So again the function f of x remains the same, a naught by 2 plus summation n equals 1 to infinity a n cos n x plus summation n equals 1 to infinity b n sin n x. Again these a naught, a n and b n are called the Fourier constants. Again, those formulas are given by a naught is 1 by pi into limits of the integral minus pi to pi f of x dx, and a n 1 by pi minus pi to pi f of x cos n x dx, bn is 1 by pi minus pi to pi f of x sin n x dx. The Fourier series expansion of f of x over the interval minus L comma L of length 2L is given by, this is called an arbitrary period, a naught by 2 plus summation n equals 1 to infinity a n cos n pi x by L plus summation n equals 1 to infinity b n sin n pi x by L. Again these three a naught, a n, b n are called the Fourier constants. Now those formulas are given by a naught 1 by L minus L to L f of x dx, a n 1 by L minus L to L f of x cos n pi x L into dx, and bn is given by 1 by L minus L to L f of x sin n pi x by L into dx. Here the interval is minus L comma L, so therefore limits of the integral is also same. Next, we will move on to the interval 0 to 2L. This is also of length 2L, and Fourier series expansion is a naught by 2 plus summation n equals 1 to infinity a n cos n pi x by L plus summation n equals 1 to infinity b n sin n pi x by L. Again, this a naught, a n and b n are called the Fourier constants. Now we will see what are the formulas for a naught and a naught, a n. 1 by L 0 to 2L f of x dx, a n 1 by L 0 to 2L f of x cos n pi x by L into dx, b n 1 by L 0 to 2L f of x into sin n pi x by L into dx. So we'll by making use of the appropriate formulas, we'll find the we'll find the Fourier series expansion of the given function. Thank you.